Section 26.3, the inner planets. So the four inner planets are the ones we're going to talk about first, and then we'll talk about the four outer planets. The inner planets are similar in their construction. They're made out of high-density solid rocks. They're closest to the sun. And we're going to go into each one in detail just briefly. But one thing I want to point out is that as the planet gets further and further from the sun, the planet travels around the sun slower. The orbital speed decreases as you get further from the sun. What that means is that the time of revolution, the time it takes for the planet to go around the sun, increases. If the planet's slower, further out, then it takes longer for it to go around the sun. You see this in the fact that the orbital period of Venus is something like 228 days, and the orbital period of Earth is 365 days. Mars is somewhere around 400 something days. I can't remember the exact number. But the speed that the planet moves is slower as you go further out. Therefore, the time that it takes is greater. So now let's just look at each one of these planets with just a little bit in depth. The first planet, the one closest to the sun, is Mercury. Mercury is the smallest planet out of all 8 of them. Pluto does not count in this case. We'll talk about that later. Mercury has a highly elliptical orbit, so it's a very flattened ellipse, very, very elliptical. Is a distance at about 0.4 AU. AU represents astronomical units. It is the distance or the average distance from the Earth to the Sun. So 0.4 AU means it's about 40% the distance from the Earth to the Sun. So it's pretty close to the Sun, and it's a very small object. Mercury has almost no atmosphere due to its small size and its location. It's got enough mass, but it can't really hold any gases to the surface like the Earth does, or any of the other planets past Mercury, because it's small, but also because it's so close to the sun that any type of gases or anything that would form some type of atmosphere would be blown away by the power of the sun, essentially. Those gases can't survive on that surface. So there's basically no atmosphere on Mercury. It is heavily cratered. That comes about from its location as well. Being close to the sun pulls in a lot of random objects, and so Mercury can easily get in the way of those random objects and get hit by them. So you see tons of craters all over Mercury. Daytime on Mercury is extremely long, and it can get really hot, up to 430 degrees Celsius. Now the fancy thing about Mercury is the way that it's locked in its orbit with the sun. We'll talk about the moon later, but the moon is locked with the Earth in its orbit so that we only see one face of it. Mercury and the sun are in a similar situation, but rather than being 1-to-1, it's like 3-to-2. And so it's for every 2 revolutions around the sun, Mercury rotates 3 times. So its orbital period is like 3 months. So if you go, and its rotational period is about 2 months. And so if you go around twice, that would take 6 months. And it would also take 6 months for the planet to rotate 3 times. So it goes around twice every time, and it rotates 3 times throughout. That's only significant because what that means is that if you look at the sun on Mercury during the day, the way that Mercury rotates and the way that it revolves around the sun, if you were to stand on Mercury during the day, which would be a very long day, the sun would rise in the sky, kind of like it does here, and then it would move across the sky, kind of like it does here. But then at some point, it would stop, move backwards, and then move forwards again. And it's entirely due to the way that Mercury rotates. There are videos of this that you can find, just like animations of what it would look like, and it's super interesting. It's not what you think the sun would do um, anywhere, but it's entirely related to the way that Mercury rotates. Again, on Mercury, nighttime is very long and cold without the sun and no atmosphere. You can't trap any heat, and so it gets really, really cold on the surface. And you can see Mercury shortly after sunset or right before sunrise, but it's going to be low to the horizon and it's going to be very dim. If you have any kind of light pollution or anything around, you're probably not going to see it. But it is visible with the naked eye in the right conditions. You're also probably not going to see it if there's any kind of objects on the horizon, because it should in general be pretty low. If we take one step out past Mercury, we come to Venus. Venus is the next closest planet to the Sun, it's second from the Sun, has an orbital distance of about 0.7 astronomical units, so it's about 70% the distance from the Earth to the Sun. Okay, so it's between us. It has a diameter of about 0.95 that of Earth. The Venus in size and in some ways composition is very much like Earth. It's almost the same size. It's closer to us than any other planet. It's made up of similar materials. However, Venus is possibly the worst place you could go in the entire solar system. Venus has a considerable atmosphere that's mostly made up of carbon dioxide. And the atmosphere is so full of carbon dioxide that you can't see through the clouds to see the surface. Venus does have a surface, but we can't see it. Even in this image, you can see the clouds. Now, because of all that gas, because of all that dense atmosphere, the pressure on the surface of Venus is extremely high. The reason we can't send things to it very easily is if we were to try to land something on Venus, it'd essentially be crushed by the atmosphere. It is, I believe it's something like 10 times the atmosphere of Earth, if not more than that. I can't recall the exact number. But it's extremely dense, and there's a lot of pressure. And because of that, the planet traps a ton of heat. If you have any questions about what the Earth might look like, were the greenhouse effect to overrun the Earth, we need only look at Venus. Venus is what happens when carbon dioxide levels in the atmosphere just get out of control. Venus would be nearly impossible to live on. It's closer to us. It's similar in size to us. It's in a region where you might be able to find liquid water if there wasn't for all that atmosphere. But we don't even bother trying to go to Venus like we do with Mars, because Venus is just so harsh an environment. It's such a terrible place to live. Mars is much simpler. It doesn't have everything that we need, but we can put it there. We don't have to worry about being crushed by the weight of the atmosphere. Venus is sometimes called the morning star or the evening star. It is the third brightest object in the sky after the sun and the moon. You can see Venus usually in the evening, right as the sun goes down, or in the morning, right before the sun comes up. It will appear to be very, very bright. It'll look like the brightest star in the sky because in a way it is. It's just not a star. It's a planet. And it just happens to be a planet that's really close to us. If you look at Venus in a telescope, much like we can see phases of the moon based on the position of the moon as it rotates around the Earth or as it revolves around the Earth, we can see phases of Venus as it revolves around the sun, depending on its position relative to us. So that is actually a really interesting thing to see if you can ever take a look at Venus in a telescope. Venus is also really interesting because unlike all of the other planets, Venus rotates in the opposite direction from the Earth and every other planet in the solar system. What that means is that whereas when we here on Earth see the sun rise, the sun rises in the east and it sets in the west. On Venus, if you could see the sun from the surface through the clouds, then the sun would rise in the west and set in the east. Venus's rotational motion is actually really, really slow. So it takes a really long time. Um, because of that, it's thought there could have been some kind of event in the past that led Venus, maybe a collision of some type, that led Venus to slow down and rotate in the opposite direction. But um, the Venusian day is longer than a Venusian year. It takes about 228 days for Venus to go around the sun, but it takes longer for Venus to rotate once on its axis. One day would be longer than a year on Venus. Now the next planet is Earth. We know a pretty good bit about this one, so we're not going to focus too much on that. I do want you to know that the reason that Earth can sustain life so well is because of its location in the solar system. We are the only planet in the solar system where water exists in all three phases naturally. We have a lot of liquid water, but there's also solid water, and there's also gaseous water as well. So all three phases exist on the Earth, and that's why we can sustain life. But in general, we know a pretty good bit about the Earth. And we'll talk a lot about the Earth in this course. Now, the last of the inner planets is maybe the most popular, maybe the one we know the most about, probably because we've visited it more than any other time. We've also sent probes and things to go and walk around on Mars and take samples. They recently just sent another one, I believe. Mars is the fourth planet from the sun, just past the Earth. It is a potential place that humans could go. It's at an orbital distance of about 1.5 astronomical units. So about 1.5 times the distance from the Earth to the sun. So it's a little ways away. Not as close as Venus, but closer than Mercury. Mars is much smaller than the Earth, about near half of Earth's size. It has a very thin atmosphere that's mostly carbon dioxide, just a little bit of oxygen. And what that means is when you have a really thin atmosphere like that, first of all, you can't exist on the surface by breathing. You couldn't breathe on Mars without some kind of apparatus. But also, Mars is ineffective at maintaining temperatures. So with a thin atmosphere, as soon as the sun is gone, the temperature will drop significantly. So the difference between day and night on Mars is extreme. 30 degrees in the daylight, that is at or around some of our hotter days here in the south, to minus 130 degrees Celsius at night. That is getting close to the temperature of liquid nitrogen, though it's not all the way there. I mean, it's pretty cold at night, and that would just be the difference between being in the sun and not being in the sun. It says day and night because you're talking about the surface of Mars, but all it would take would you to step in a shadow, and you'd find that difference in temperature, because without an atmosphere, even shadows can't hold heat. Mars obviously is the present focus of exploration. We try to go there because we can. It's safer than trying to go to Venus. It would be more useful. We can't do anything on Venus, but on Mars we could put things there. We couldn't have an atmosphere. We could build objects where we could have artificial atmospheres, things like that. And so there's a reason that it's a focus of research. There's a reason that we're looking into it, because it could be made into being habitable over time. And there's even evidence for things like water, and that's one of the things that those new Mars rovers are going to look for. But they've also found that Mars used to be geologically active, used to have volcanoes and things like that. Mars is really important in terms of space exploration. It's the next step beyond going back to the moon.